This is Srikanth, Assistant Professor of Tribly Department. In this session, I am discussing the single phase AC circuits. Single phase AC circuits. Let us go with the basic definitions corresponding to single phase AC circuits. Here, AC is nothing but alternating current. That is, alternating current is nothing but the current is alternating. That is, from time to time, it is varying the value, that is correspondingly with respect to the time, the value is varying. Here, the alternating quantity, the name itself says it is alternating from time to time. So, when we are going with one particular instant at zero time, the value here is 0. When you go on increase the value, when you go on increase the time, then the value is increasing, and this value increases up to 90 degrees, up to pi by 2 time, and then after this value will decrease, and then this value again increase in the negative direction and again decrease to 0. So like this, which is going to have the maximum values at 90 degrees and 270 degrees, that is at pi by 2 and 3 pi by 2. And this waveform can be called as sine waveform. This waveform is sine waveform. That is, if we write the equation for E of t, that is Em sine. Here we are considering that it is varying with respect to omega t, sine omega t. So this is the voltage equation corresponding to this particular alternating quantity. An alternating quantity changes continuously in magnitude and alternates in direction at regular intervals of time. That means it is going to change the magnitude after certain time. It is going to reverse its direction, that is from positive to negative and negative to positive. That is nothing but alternating quantity. Now, corresponding to the alternating quantity, what are the basic definitions? Let us go through it. Please, the first one is the amplitude. Amplitude is nothing but it is the maximum value attained by the alternating quantity, and it is also called as maximum or peak value. It is also called as maximum or peak value. That is nothing but amplitude. It is the maximum value attained by an alternating quantity, also called as peak value. Let us see here. This EM value is nothing but the maximum value, that is peak value. And the next one is the time period. It is the time taken in seconds to complete one cycle of an alternating quantity. That is, whatever the one time taken to complete one cycle is called the time period. That means one cycle is nothing but which is going to have one positive half cycle and one negative half cycle. So in that case, it is going to complete one complete cycle. That is nothing but the time period. That is, here you can see this is one positive half cycle and this is one negative half cycle. and whatever the time taken to complete this one positive and one negative half cycle is called alternating quantity. Sorry, is called time period. Here, the next definition is instantaneous value. It is the value of the quantity at any instant. How we are going to represent the value, the function of alternating quantity is called the instantaneous value. And the next quantity is the frequency. That is, it is the number of cycles that occur in 1 second, or the inverse of time is called frequency. It is how many number of cycles are completed in 1 second is nothing but the frequency. The unit for frequency is hertz or cycles per second. How many number of cycles per second? So here the relationship between frequency and time period can be derived as follows. That is, time taken to complete f cycles is 1 second. Here, time taken to complete one cycle is 1 by f seconds. So here we can directly say that frequency and time are inversely proportional to each other. And now we need to calculate for any alternating quantity. We need to represent. We can't say every time with the instantaneous value all these things. So we have to represent the quantity in terms of the average value or RMS value. Here we are representing the average value of sinusoidal current. Here how we are going to represent the average value of a sine function. Here, for calculating the average value of n numbers, if let us take the average value is equals to average value of n numbers is equals to summation of ni by n. That is where I is n numbers. So the sum of all the numbers divided by n is nothing but the average value. And here also, whenever we are calculating the average value for any function, we are going to calculate the average value by calculating the area under the particular curve divided by time period, time taken to complete that particular area is nothing but the average value of any given function. Here, whenever we take the average value for a sine function, here sine function is having both positive and negative half cycles. When we are having positive and negative half cycles, if we take the average value of both the cycles, both the half cycles, then we are going to get the average value as 0. So, in order to get the average value of a sine function, or we can call this function as symmetrical waveform. What is symmetrical waveform? Symmetrical waveform is nothing but it is the waveform which is going to have both positive and negative half cycles with the same shape and with same equal area. With equal area, then that waveform is called symmetrical waveform. So for symmetrical waveform, we have to calculate the average value for half cycle time period. For half cycle time period. Here let us consider the average value of any function. Average value of any function, average value of any function can be function average is equals to 1 by time period into f of t dt. 1 by t integral f of t dt. The calculating of area under the curve is done with by integrating the function. Integrating is nothing but addition of the numbers within the limits, addition of that particular function values within the limits is nothing but the integration, that is nothing but the sum of all the points in that particular function. So here, in order to calculate the average value of this particular sine current, average value of this particular sine current is equals to. So first let us consider what is the function. Here the function we are having a sine function with a maximum current of, with a maximum value of current as Im, that is Im sine omega t. Here I average is equals to 1 by pi, that is the time period for this half cycle is pi. So here, in order to calculate the average value is equals to 1 by time period. Here time period we are considering as half cycle period. We are considering as half cycle period, that is half cycle time period is pi, that is 1 by pi integration 0 to pi id omega t. That is here the function id we are writing it as Im sine omega t because the function is varying with respect to sine function, that is Im sine omega t d omega t. So from this, if we integrate this function sine omega t d omega t, that is here Im by pi into integration of sine is minus cos omega t, where the limits are from 0 to pi. So from this Im by pi into minus cos pi is minus of minus 1 minus cos 0 value is 1. So here we will get it as 2 Im by pi, that is equals to 0.637 Im. 0.637 Im. This is the average value of a sine current, that is 2 Im by pi or 0.637 Im. That is nothing but 63.7 percentage of maximum value. This is the way we are going to calculate the average value. And next we need to calculate the RMS value of a sine function, that is root mean square value. Here the root mean square value is, how to calculate the root mean square value of this function is, let us consider the maximum value of a function as Vm, and here we are taking it as minus Vm 0, 5, 2 pi. For RMS value, here we are taking root mean square value, so always square value will be minus into minus will become less. So we are going to get the value something, even though if we consider a full cycle period or half cycle period. But for symmetrical waveform, you have to consider either full cycle or half cycle. But unsymmetrical waveform, we have to consider full cycle period as the time period. So here, in order to get the RMS value. What is RMS value? Root means square value. That is nothing but if you take n number of items, that is summation of ni square by n. And for any given function, how to calculate the RMS value? RMS value of any given function is equals to function square f square of t divided by t whole power 1 by 2. That is the RMS value. So here, for calculating the RMS value, we have to go with the f square of t divided by t into whole power 1 by 2 integration. Here, the sum is nothing but, for any function, sum is nothing but integration of the function with respect to the given time period. So here, the RMS value is equals to integration of Vm square sine square omega t, Vm square sine square omega t d omega t divided by the time period is 1 whole power 1 by 2. Here, let us take 1 by root pi outside, 1 by root pi outside. Here we are going to have the limits from 0 to pi. So here we are taking Vm also outside. Vm square whole power 1 by 2 square and root will get cancelled. We are going to have Vm into integration of sine square omega t d omega t whole power 1 by 2. The limits are from 0 to pi. Here sine square, we cannot integrate sine square omega t directly. So we are going to take Vm by root pi into integration of sine square we cannot do. So we are writing the sine square into 1 minus cos 2 omega t by 2. 1 minus cos 2 omega t by 2 into d omega t whole power 1 by 2, which is equals to Vm by root 2 pi, Vm by root 2 pi into integration of 1 with respect to d omega t. Integration of 1 with respect to d omega t is omega t, where the limits are from 0 to pi, minus integration of cos 2 omega t is sin 2 omega t, where the limits are from 0 to pi whole power 1 by 2. Here Vm by root 2 pi into, here we are going to get, if we substitute the limits, pi minus 0 minus sin 2 pi value is 0, sin 0 value is 0. We are going to get only root pi. Here root pi will get cancelled. We are going to get the value as Vm by root 2. That is equals to RMS value of any function, any sine function will be equals to whatever the maximum value divided by root 2. RMS value is nothing but maximum value by root 2. This is the way we are going to calculate the RMS value for any given sine function. And next is, from this RMS value and average value, we are going to calculate the form factor and peak factors. So here the form factor is defined as the ratio of RMS value to the average value of the given function. Here for sine waveform, form factor is equals to RMS value by average value, where form factor is equals to RMS value by average value is nothing but here we are going to get Vm by root 2 is 0.707 Vm divided by 0.637 Vm, that is equals to 1.11. Here, because of this form factor 1.11 only, all our transformer ratings and our transmission line ratings also given in the multiples of 11, that is 11 kV, 22 kV, 33 kV. Like that we are going to have the multiples of 11 will be there, because when the form factor is nearly to the same value of voltage, so which will makes the easier calculations for our system. And the next one is peak or crest factor. It is defined as the ratio of peak value to the RMS value of the waveform. So here for a sinusoidal signal, peak factor is equals to peak value by peak value by RMS value, that is equals to peak factor is equals to Vm by Vrms, that is Vm by 0.707 Vm, that is equals to 1.414. And now let us go with some small problems. That is a sine wave. Let us go with the problems. A sine wave has a peak value of 25 volts. Determine the following values: RMS value, peak to peak value, and average value. Here the maximum value is given. When the maximum value of any sine function is given, we can calculate average value and peak to peak value and RMS value. We have already derived the equations corresponding to the average value and RMS value. Peak to peak value is nothing but from peak to peak, that is from positive peak to negative peak, that is Vm minus of minus Vm, that is nothing but 2 Vm. So here first let us calculate the RMS value. Here the RMS value is equals to Vm by root 2, that is 0.707 Vm, that is equals to 0.707 into Vm value is 25, that we are getting it as 17.675 volts. And peak to peak value is 2 Vm, that is equals to 2 into 25, that is 50 volts. And the average value is 2 Vm by pi, that is 0.637 Vm, that is 0.637 into 25, which we are going to get it as 15.9 volts. This is the way we are going to calculate the average, RMS and peak to peak values for any sine function. And now a sine wave has a frequency of 50 kilohertz. How many cycles does it complete in 20 milliseconds? So here the frequency is given 50 kilohertz. Frequency is given 50 kilohertz. And how many cycles does it complete in 20 milliseconds? Here given time is 20 milliseconds. So here how many cycles are nothing but we have to calculate the frequency. We have to calculate the frequency, that is equals to 1 by time period, that is 1 by 20 into 10 power minus 3, that is equals to 50 hertz or 50 cycles per second. 50 cycles per second. So in this session, we have discussed what are the basic definitions corresponding to alternating quantity and the average and RMS values, form factor, peak factor, and basic problems corresponding to the alternating quantities. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.